Hello everyone. Okay, hello everyone. I'm Charlie from team 20325.
Hey, I'm John 6566.
So we have this kind of weird like dual presentation
It's
thing.
actually super
Yeah, yeah. So our team's half of the presentation is kind of about how to find success as a team and just kind of what we learned over the years as a team.
And we're going to take that, break down the team social hierarchy, how you want to set your structure, and we're going to give an example of how great leadership and teamwork can work in some code.
So let's get started.
So the first thing you're gonna wanna focus on are your new members. You need to look at what strengths they're bringing to the table and make sure you put them in categories that they're gonna be excited about and that they're interested in so that they can help your team with the competition.
And another thing you definitely want to focus on, especially at the start of a season, is observing other people's robots and just seeing what kind of stuff can you glean from them. So I'm not saying, steal their designs and replicate it completely, because that defeats the whole purpose of robotics. But what you can do is because when you're starting off in the season, you're not going to have a completely efficient robot. You're going to have problems. You're going to make mistakes. So you can see what other teams are doing right and kind of incorporate that into your design, but add a unique element and make it yours. So if we can go to the next slide. So an example is like our robot. So at the start of the season, we used this design, which is like a dual arm design, and it worked. We were able to score pretty efficiently, but it wasn't perfectly good. And we saw a lot of people using something like this, like a linear slide. So eventually we did switch to that because it was a lot more efficient, but we added an active like weight system in the back. I don't think it's in this picture specifically, but we added a weight system in the back, which was unique in that it balanced the robot more, and it actually got us an Innovate Award at state. So that's pretty cool.
It's great to have a good robot to help you win in competitions, but assuming that you're going to win every single time is a little wishful thinking. So outside of the parts of your robot that help you when you're actually going to the competition, judging is a very good way to move on. So having judges that have judged before to mentor you, to tell you what to highlight about your robot and what to make better about it is a very good way to get you to move on, such as cleaning up messy wires or highlighting a interesting design that you made that's very unique, such as the counterweight system he was talking about. And then once you're in the competition, there are a couple things you need to be prepared for to ensure that you do as well as you can. The first one is judges. As they come around, you want to make sure that you have very good answers prepared to the questions they'll ask you. So you want to ask the judges that have judged in the past, they'll give you what they asked, and you can kind of base off those questions because they'll likely be very similar. And then once you have those, it'd be pretty sad to get a good answer and then just not even tell them because you're not there. So you want to make sure that you have one person from each role, like outreach, engineering, all that at the station at any one time so that you can answer any question they have. And then there are a lot of problems that will likely happen during the competition. Things break, code breaks, injuries can happen. And while asking help from other teams is a very good idea, it's not something you should rely on. So you want to have extra parts, you want to have a laptop to fix your code, and you want to have a notebook because if a team member leaves and you don't know much about what they do, you want to have your notebook with you so you can kind of look through it, see what they do, and you can answer questions to the best of your ability.
Yeah, so then branching off of what you said, social hierarchy, right? Make sure that everyone in your team has a role and has a way to learn. So at the bottom of us, we have a new participant. They should go on the first. They probably have very limited STEM experience if they're coming from the middle school level, or if you have from some AP Physics C coming in as a senior. It's important that they're getting all this information from team members, and then team members' main job is to get experience so they can move into what we call a stable and fluid position. So that's our lead code, lead engineer, head of CAD, and head of outreach. So although our team captain, which is me and our assistant guys with Ethan, although we have these roles, we also serve on these other committees. For example, head of outreach, I have 3 guys on my team who are head of that as their main staple, but we also have multiple engineers, multiple coders, Because the whole thing is sustainability, making sure that as soon as we start having team captain leave, color leave, we get people coming up after that. Because the most important part about force integration professionalism and competition, and we can't inspire that in our team without making sure that the new guys coming out are prepared for the future.
Alright, so the generating concepts. So we had a style of drawing we used last year that was mentioned by one of our favorite teachers, and it was called sea sketching. So we sat at a table like this, and we all had designs. We drew up whatever we were thinking without talking to each other. And then after that, we shifted all the papers around the table, like one of the drawings you see there, and we all acted on each other's design, getting like 5 or 6 different parts of the design, eventually ending up with a chassis that looked like this, which we actually used in the competition. And that allowed us to have all of these like modular parts on there because there's so much lightweight, strong frame that we can like add things onto, take off, simple, fast modifications. So,
All right, cool. So of course, like any good team, we want to make sure that we're always improving and that we're developing the next generation of what we're working on. So as we're going throughout the year, we're pretty satisfied with what we had, but we recognized a couple features we wanted to change, such as we wanted to be able to condense our robot as much as possible. But right before we started actively building our next iterations of our robot, one of our teacher mentors had told us about swerve drive. So we got to learn a little bit about that as Area 52 was talking about. So we were looking at differentials and coaxials and like which one do we think would be most reasonable for our team of what we're working on. We were trying to make that decision. We ended up coming down to coaxials because we could run servos to turn our motors instead of using multiple motors to do the same thing. But of course, right, as Area 52 is talking about, that's going to depend on what your robot looks like and how it's functioning. So here we have pictures of what our robot would look like in CAD if we had used vertical coaxial systems, which is what we had developed initially. This is kind of the coaxial cut in half so you can see what would be going on. You have your motor from the top turned into velvet gears, system of gears, or if you have sprockets, you can chain the sprocket, make that a little easier. Ultimately, it would start looking like this. We started putting it together, but as we're doing that, we started thinking, hey, what if we could take this unit, put it in the middle of our robot, and use that to drive our robot by itself? So, Jackson, can you get the next slide? We started working on that. So because we need more torque, we decided to double up our motors on one side, put that in the middle of our robot as a modular system. So when we were doing that, got thinking, okay, cool, now it can go forwards, it can turn, right? But it would stay constantly facing in one direction because it's only the motor in the middle that's turning. So we decided to put out on the outside of the robot wheels that can steer and turn us, and then on the opposite side, inverter wheels that can track that movement so we can constantly self-right and always know where we are. So what this is getting at is super important. This is, from an engineering perspective, super useful. It allows us to do a lot of different things. As you can see over here, we can have greater access to the outside for outtakes. Like in last year's game, if you need to reach out and grab a cone, they need to put on your next arm, they can go out over the mower. You need to have access to the outside, right? Pretty basic, but that plays into a lot of how well you can perform during the game. Sorry. Then it also gives you greater range of movement because you can be going forwards, be turning your inward axle or motor, and still turning your robot separately because they're on independent systems. It also allows for faster driving because your mechanism wheels no longer have to work against each other because you have one grippy wheel like Area 52 is talking about, which really awesome design. Love it. Then, yeah, so a lot of other things. We're running short on time. Can we go to the next slide? Sorry.
Yeah.
Okay. So this is where it kind of comes down to like, why is this design important, not just to our engineering and CAD teams and all that, but also to everything else? And I think Carter hit that really well.
The kind of lead roles that we have are programmers are behind the head programmer. We have the head driver who's having a good meeting today because he is the outreach person. So John, he schedules all the things and manages like meeting at our local library and stuff like that. And the lead engineer, Ethan, and the notebook person. So this year we can actually have a notebook person. So we have like all of us coming together and like doing our little parts in the notebook, and then basically just editing all of the notebook individually so that we can fix all these little tiny mistakes here and there that we don't quite catch.
I throw in one more thing. Awesome. So what this is getting at is a lot broader of a concept than just the what we call UFO drive, because you can go forwards and turn at the same time. It's kind of like a UFO when you're spinning. But it touches on internal networking, right? Internal networking, essentially, like we think of exterior networking, like I'm working with my libraries, I'm working with my my other teams, we're getting together, we're doing scrimmages. That would be a great example of external networking, but in this case, since we're doing internal networking, it's very self-explanatory. We're working within our own team to create connections that are not only meaningful, but essential to our success. And that's where this last part comes in. Incorporating a systematic theme, in this case, our UFO drive, boosts the productivity of our team as a whole and its products. It's not just weighted to one side. Any decisions we make are balanced. It's to help every aspect of our team. We're back to Johnny.
We really thank you for your time, letting us present the last minute. It's awesome. If you have any questions, please ask us. I know we're trying to wrap up. So limited if you have it. Awesome. Thank you guys. Really appreciate it.